Right on. Hi, good afternoon, good evening, good morning, good day to all of you. Thanks for joining us today. My name is Josh Long. I work on the Spring team. I'm part of Tanzu, a division of VMware, where I serve as a Spring developer advocate, and I have served in that capacity since 2010. Still going strong. Every day I find something new and novel and amazing to love about this ecosystem and the sort of ambient communities around Spring. In that journey, I've been lucky enough to have been made a Java champion, a Kotlin Google developer expert. But throughout it all, I am at your service, my friends. So should you have questions, comments, feedback, whatever, don't hesitate to find me there at those various coordinates on my screen. I work for you as much as I work for the Spring team. And today, my friends, we're going to talk about a topic that's near and dear to my heart, which is building modern applications that work well, that do the right thing in a Kubernetes context. And so to get started, because we have so very little time, so very little time, we're going to go ahead and start building some software here at my second favorite place on the internet. Obviously, my first favorite place on the internet is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It's better than Disneyland, which I make that joke a lot, but I'm hearing about the horrible news out of Florida right now. And so, I hope everybody's okay. Anyway, we're going to go to start.spring.io and we're going to build a new piece of code, and we're going to take advantage of our little time together today to look at features in the Spring ecosystem for building apps intended for Kubernetes, of course. But we're also going to take a look at some of the new features in the to be GA soon Spring Framework 6 and Spring Boot 3, both of which are due by the end of this year. Actually, I think December-ish, right? Maybe even November. I don't know, but soon, right? Soon enough that it's time to start kicking the tires, downloading the bits, trying things out, etc. And so we're going to build an application using Spring Boot 3.005, which just came out less than a week ago. We're going to build a new application. We're going to just call this customers because why not? I'll use the reactive web support. I'm going to use H2, which is an in-memory embedded SQL database. And we're going to use the Spring Boot actuator. And I'm going to use R2DBC, which is a reactive relational database connectivity abstraction. And we're going to write, software, just general basic web application kind of software here, excuse me. And we're going to use Java 17. Now, obviously, Java 17 is the current long-term supported version of Java. It's a great fit for your cloud-native environments, your cloud-native atmosphere. But it's not the only one, obviously. There's Java 19 and 18, both of which are great choices as well. Really, anything 17 or later is great at this point in time. That said, Spring Framework 6 will expect Java 17 as the baseline. Now, that may seem a little aggressive, given that it's only a year old, but consider the timelines of a given Spring Framework generation. Spring Framework 5 came out in September of 2017. So that means that in a few short days, it'll have been more than 5 years since we released Spring Framework 5.0 back then. Now, here we are staring down at Spring Framework 6, and you can extrapolate a little bit further into the future. And just if that timeline, if that trend continues, then maybe in theory, we could be another 5 years out before Spring Framework 7 arrives, right? And during that time, there will have been two new releases of Java every year for the next 5 years. That's 10 versions in addition to the current Java 19 that we already have right now, that's GA. So what, Java 29, and you can still write Spring Framework 6 code against it, right? It's going to be a very conservative, long tail of support there if the current trend holds. So Java 17 may seem aggressive, but it's not. It's a great choice. It's also technically superior in every way. It's faster, more secure, more performant, more robust, more organizations operational and so on. It's just technically superior in every way. It's also morally superior in every way. You won't like the look of sadness and despair in your kids' eyes when they find out that you're still using Java 8 in production. Don't do it. Be the change you want to see in the world. Do the right thing. Use Java 17. Java 17 is the right thing to do in Java in 2022. And just judging by the version number alone, just purely by the version number alone, I think we can all agree that Java 17 is more than twice as good as Java 8. And so by that metric, if nothing else, hopefully you've been persuaded that you need to upgrade. So we're going to go ahead and hit generate. We're going to open this up in our IDE, UAO customers.zip. And we're just going to build just a simple application, nothing fancy here. Let's see, got that. presentation mode. All right, and there we go. Application, customers application. Very good. So simple application. We're just going to write some data to the database. So I'll call this, I'm going to create a DTO to represent that. Here, let me make that font a little bit bigger. There you go. Integer ID, string name. Look, no lumbuck. Isn't that nice? Isn't that nice? So we've got this annotation here, and I'm going to create a repository. So reactive, a customer repository extends reactive CRUD repository managing entities of type customer whose primary keys of type integer. And then, of course, we're going to write a Spring Bean that starts up. And when it starts up, it writes some data. So data listener. And we're going to do that, of course, using these reactive APIs. So var names. And we're just going to have some names on the Spring team. Dr. Sire, of course. And let me see. I'm on the Spring team for reasons that will forever elude me. Madura, she's amazing. Yushin, also legendary. Olga, oh my, what an amazing engineer. Who else? I'm struggling to find somebody that's like crappier than I am, but it's just hard. I am probably the dregs on the team. I'm definitely the bottom of the barrel. So I guess that's the list of those people. But who's awesome? Who else is awesome? Well, okay, we got Jürgen, we've got Stefan. Did I already get Stefan? No, I don't think I did. Whatever. So there's some names, and I want to visit each name. I'll say names.map new customer, and I'm just going to create the value there, and I'll pass in the name. And for each one of those, I'm going to write it to the database using the injected repository that we just created. Okay, so customer repository, and we'll say repository.save C, and that'll give me a reactive pipeline. And I want to then just visit all the results that come back from that save. So as it's writing out, I'll just print out the results that come back from that. Okay, so very simple little pipeline, not a very big deal, just a little pipeline wherein I write some data to the database in a Lambda that gets invoked when the application starts up. This is just for our demo. You wouldn't do this in production code. Obviously, we're going to need some schema. So I'll go over here and we'll create a new file called schema.sql, and I'll create a table called customer ID serial primary key name var car 255 not null. Okay, good. Yeah, good. So we have our basic application. I guess we need an HTTP endpoint. Let's do that. So we'll create a router function, functional reactive HTTP endpoint, server response, HTTP endpoint. Okay, return, route, and build. Customers, new handler function, and voila. Okay, so there's our basic HTTP endpoint. And all we're doing is we're just taking, let me see, server response. We're just taking the data that comes back from our repository here, and we're going to represent that in JSON. So repository at find all. Very good. And it'll be of type customer.class. Voila. Okay. Not a big deal. Very, very trivial. Let's just run this and see what we get. I can introduce some static methods here to clean that up a little bit and restart. Okay, so now localhost, move this over here. Actually, it's fine there, leave it there. So localhost customers. Very good. So there's our data, right? There's our application. We have 7 records in the database. Great, it's working fine. That's not actually all that impressive, right? No, anybody can do that. What matters is how well these things work in production. So the first thing that we care about when we start writing Spring Boot applications is observability, right? And this is one of those things where Spring has really gone to great lengths to make this as easy as possible. We're going to talk about the possibility of using AOT, the ahead of time compilation mechanism in Spring Framework 6 and in Spring Boot 3 in just a minute, but consider that for GraalVM today, GraalVM native images today, the choices for Java agents are very slim, right? That doesn't work well in the GraalVM world at the moment. So if you want to do observability, if you want to instrument your code, that has to be done in terms of the runtime code, as opposed to this Java agent that sits underneath your code base. And so to this end, I think you're going to find you're well prepared, well situated with Spring Boot, because, for example, we have the Spring Boot actuator module. And the actuator module is a set of managed HTTP endpoints that give you information about the health and the state of your service. So let's say I want to show the details. Okay, always, I want to enable the Kubernetes probes, thank you, and so on. So now I can rerun, having made those changes just for the demo, again, just for the demo. I go here, localhost actuator, refresh, and you can see I've got these endpoints like health and beans and caches and all that kind of stuff. Health gives me an enumeration of all the different subsystems in the application that, were they to fail, would imperil the state of the overall service. So, for example, the file system and the database connection and so on. If any of those broke, then of course the application would as well be broken, right? But of course in Kubernetes, we don't care just about health. We care about two particular things: whether the service is ready to be put into production, that is to say whether it's, readiness probe, that's the readiness probe, whether it's ready to be put into production, or whether it's able to stay in production via the liveness probe. And both of those endpoints are provided for you out of the box, okay? Now, of course, you can use the Spring event bus here, and there's an event bus you can use to trigger an event that then tells other components in the application to do something or about some change state. One of those events is an event that you can use to signal that the probe should reflect that the service is sick. So new handler function, and here I'm going to say availability change event publish, and you're going to need a pointer to the Spring application context, right? This is in order to publish this event. So we'll say application context, and then the event will be liveness state broken. Okay, so I'm publishing an event. When somebody calls this endpoint down, all we're going to do is return, okay, but we're going to, let's see, but build, we're going to return okay. Basically, it's just going to be void. But what we're going to do is we're going to publish an event, and that'll tell everything in the application that the service is down, and therefore it should reflect that in the probe. So let's go ahead and restart this. Okay, and you can see if I refresh this, it says up, go localhost actuator. Sorry, it's just called down, isn't it? Down. And now you can see it says down there as well. So, you have the ability to inform these different endpoints here to better reflect the state of your service. Now, the question is, what happens when your health indicator goes down? And by the way, there's other things that I kind of gleefully breezed through before I move on. I forgot to mention metrics. Metrics is great because it's a set of statistics about the state of your application. This is powered by something called Micrometer. Micrometer is a framework for capturing metrics, right? So Micrometer, here you go. And it's a vendor-neutral application metrics facade for which there are implementations for AppOptics and Prometheus and Google Stackdriver and StatsD and Wavefront and Netflix Atlas and Datadog and all that good stuff, right? There's different implementations here, and they can just automatically, transparently publish or export your metrics to the time series database of your choice. Okay, so we've got the question of what happens when your application is sick, when it goes down? Well, of course, Kubernetes is going to come along and it's going to take that pod out of rotation. And the question then is, what happens to your ongoing business logic? What happens to the ongoing state in your application? Obviously, you want to make sure that just, that doesn't get just destroyed right in the middle of the work. You want it to be as graceful as possible. So we're going to use graceful shutdown. So shutdown equals graceful. And here we're saying when the application is in the middle of being shut down, but there's existing in-flight transactions, then we want to make sure that we have a 30-second duration. You need to make sure that you specify the corresponding value in your Kubernetes deployment or pod descriptor here for the liveness. But once you've configured that value, you have 30 seconds in which to taper off any existing in-flight work and make your application ready to be shut down. There's a bit of a delta between sig term, which is a suggestion really, and sig kill, right? Where you're actually sending the command to actually forcefully stop the process from running. And this 30 seconds gives you time to finish off any existing work. In addition, Spring Boot will automatically finish, it'll finish off an existing threads or requests, but it won't allow new ones either. So that makes it very, very resilient, right? It does the right thing when being started and stopped gracefully. Okay, so now I've got an application. It's observable. We know how we can proceed from here. One of the things that's really nice about Spring Framework 6 and Spring Boot 3 is there's this new observation API which unifies metrics and tracing, and we'll have more to talk about that. We'll have more to talk about that in the days and weeks leading up to Spring Framework 6 and Spring Boot 3 coming out again later this year. But for now, suffice it to say, Spring Boot is a great way. It's built to support observability. Now, I've got this application, it's observable. I might have configuration, I've got some configuration in here that I've drawn from the, that I've drawn because I know this is good for the demo, but these are things that are really only available in Kubernetes, right? I don't need the probes if I'm not running in Kubernetes, for example. So I might want to store this stuff in a way that I can get to it from Kubernetes. And one way to do that in a Kubernetes context is to use a config map, right? A config map or a secret, which are basically dictionaries with keys and values that you can then make accessible to your application via either the environment as environment variables or as a directory that's been mounted on the file system called a volume. So, and we call this directory structure that results from using that config map as a volume. We call that directory structure a config tree. So basically, I can import that config. I can say, I want to bring in optional configuration. And by the way, there's schema resolvers. There's ways to import configuration into Spring Boot from all number of different places, including HashiCorp Vault, Apache Zookeeper, Console, Spring Cloud Config Server, Azure Vault, and Google's equivalent. All these things we have implementations for. But let's just talk about Kubernetes here. Config tree. I'm going to tell it I want to get the configuration from my home directory /config, right? Now I don't have a directory like that. Make dir config cd config lsla pwd. So there you go, jlong desktop config. I want to resolve that configuration from this config tree. Let's just imagine I'm running in Kubernetes and I can say echo 8080 is, 8081 to a file called server.port. So cat server.port lsla. So you can see that is a property that I would normally specify to override the port on which the application is running. Here, we're imagining that this is running in Kubernetes and that it would be available in a structure that looks like this. And so if everything goes to plan, the application will start up on port 8081, not 8080. Let's go ahead and restart it and see what happens. Okay, so there we are, 8081. It drew the configuration from the right place and it's working. So now we have, the ability to pull configuration in from different places. Obviously, in this case, I just want 8080, but you get the idea. It's very easy to support config maps and config trees and all that kind of stuff. Now, what about packaging, my friends? Well, packaging, of course, is very important. You've got to get your application into production. In production, they expect containers, and ideally, they expect very efficient containers. So the first thing that you can do with Spring Boot is to take advantage of build packs, right? Build packs are a cloud-native computing foundation that allows you to take an application artifact, be it a Java jar or Tomcat war or a .exe from .NET or a Ruby on Rails app or Python app or whatever, right? And it applies a recipe to take that input artifact and turn it into a container complete with all the latest infrastructure required to run an application that matches the shape of the thing you're doing. So, for example, Java apps need a JVM, so it'll download a JVM and make sure that you have that, and it'll make sure it's got the latest security patches, and there's hooks there to make sure you have different Java agents and SSL and all that kind of stuff. It's all cared for because this is a build pack that reflects the needs of large bases of people that deploy to Heroku, people that deploy to Cloud Foundry. These are huge cloud projects that have lots of different users, all of which have particular use cases and that have been borne out by and supported by these build packs. So this is not just your bespoke homespun Docker file. This is something that has been tried and true and built to be bulletproof over more than a decade in some ways for a number of different projects. So we know how to run and containerize Java apps, for example. We're the Spring team. We don't know much, but we know enterprise Java. Ditto for the build packs for other platforms and languages, right? Those are the sum total of the entire ecosystem, not just something that you put together trying to get it to deploy before dinner last night, right? This is a very mature, consistent way to get reliable container images in your organization. So you can use that. It's great, right? You can actually use the pack CLI, and you can use it to just pack build and then point it to your artifact. Or if you're using Spring Boot, and we are, you can just do Maven Spring Boot : build -image, and that'll actually generate a Docker image for you that you can then Docker tag and Docker push. But I want my application to be as efficient as possible. And remember, today, these days, applications on the JVM, they're not, Java has a long history, and in its long history, whenever it's had a choice between being small or fast, it's always chosen fast, right? And sometimes to the detriment of its size, of its footprint. And that doesn't really make all that much of a big difference if you're just running a few apps on a server somewhere, because we have, most individual servers have more than 1 gig of RAM, for example. So it's no great shakes to do that. But today, in the world of the cloud, where everything is metered and you're encouraged to keep your form factor as small as possible so you can play the most efficient game of Tetris possible with your service infrastructure, well, yeah, it gets to be a little unwieldy. But consider what amazing things that JRE has given us. The JRE, the Java runtime, the platform, is a miracle. It's an amazing piece of infrastructure. It's more than I reckon. I don't know. Nobody's told me anything. I just work here, people. But I reckon it's got to be, right? It's got to be like more than $1 billion of R&D and infrastructure over the 25, 26, 27 plus odd years of Java's useful life so far, right? Think about all the people, all the R&D, all the hours, all the the conferences. My goodness, it's got to be just a crazy amount of people. I don't know how much it is worth, but it's an amazing piece of code that we get to use for free, is my point. And one of the things that's so amazing about it is this just-in-time compiler, which looks at successively and frequently accessed pieces of code and adapts them into native operating system and architecture-specific binaries, right? So Mac binaries, Linux binaries, Windows binaries, etc. The result is phenomenal. It's why you can actually take a mediocre Java application and deploy it, and sometimes it'll actually be faster in terms of handling transactions and so on than a well-written C or C++ application. So many of which are burdened with memory management issues, right? They have these little like hiccups of memory usage where you acquire the resource, you malloc the RAM, do something within it, and then you free it, right? So those little bursts of RAM. The JVM, on the other hand, has a garbage collector which manages RAM for us off to the side when it needs to and no sooner. That's one thing. So our code isn't burdened by these constant little pauses to handle memory management. And then second of all, we have the just-in-time compiler, which turns our code into native code. So we get the benefits, we can have our cake and eat it too most of the time. And large organizations take advantage of this dynamic. They know that Java will turn into blazing fast code if you access it enough. So they pre-warm their binaries before deployment. But if this just-in-time compiler is so amazing, then why not just proactively have it, all compiled into native code? Why do it adaptively at runtime? And by the way, this makes a lot of sense. If you think about it, we have a C++ compiler that sits in your running Java code, compiling native code, right? As you have like incoming HTTP requests in the same process space, there's something that's actually doing native compilation, right? That native compilation takes time and energy and resources. It can add dramatically to the footprint of your running Java app. So the question then is, why not just proactively compile it into native code? Why not just have that upfront, especially since I am going to be running on a Linux binary in a Linux container, in a Linux host. I'm no longer worried about whether I've got big Indian or little Indian for somebody who's accessing my machine from Spark or something, from some other operating system of yours, right? This is not my biggest problem, is applets. That's not my biggest thing these days. So why not just turn it into a Linux binary that works well on Linux or whatever operating system it happens to be running on, and forsake the Java write once, run anywhere? And that's the value proposition behind GraalVM's native image compiler, which I'll heretofore interchangeably refer to as just GraalVM. So we want to support that, and Spring does. It has a great support for that, especially in Spring Boot 3 and Spring Framework 6, where we have a new AOT mechanism. But the reason you have to motivate why we have this, let's talk for a bit about what GraalVM does. GraalVM has a closed world philosophy. It looks at your source code and it tries to foreclose on the possibility of any dynamic funny business. Because if there's any funny business, about which it doesn't know, then you're going to get into trouble, because what it's going to do is it's going to throw away all the types that it cannot be 100% sure you're going to use at runtime. This means that the resulting binary is very small. It gets rid of everything in your code on the class path or in the JRE that isn't being used. It's called the reachability analysis. So it goes through your code, scanning for all the types that you are explicitly using, and it puts that and it stores that list off to the side, and everything else it throws away. And then the resulting binary, the native heap, only has those reachable types. This is a very, very nice result because you have less time spent loading things and accounting for things and reading things and all that. It's just the stuff that your code cares about directly. The problem is that Java is a very dynamic platform. It goes well beyond what any deterministic sort of non-deterministic static compile time analysis can ever hope to identify. So, for example, reflection, serialization, proxies, loading things from class path jar resources like a property file or an icon or something. All of that stuff is stuff that you need to tell GraalVM's native image compiler about, or it'll throw it away and it'll fail to work at runtime. And so something needs to go through your code base and provide all these hints. And in Spring Framework 6 and in Spring Boot 3, on top of that, we have a mechanism that automatically compiles all this hint metadata for you. There's even a whole component model. You can now write code, Spring Beans, Spring components that actually run at compile time and that have a chance to sift through all the beans in your application context and programmatically register configuration for them. I'm not going to show you all of that right now, but what we're going to do is we're going to create a native build. So -p for the native Maven profile, -d skip test, because, you know, what's the time look like after all, and so on. So I'm going to let that run, and we're gonna go ahead and wrap up this demo here very quickly by seeing what we get. And if you're using native, by the way, you can also use build packs to create a native binary. So you, instead of using a jar inside of a Linux binary, you get a native Linux container, Linux binary inside of the Linux container, even though you're compiling on your Mac, for example, and they can just Docker tag that and Docker publish it and use it in your Kubernetes deployment of choice, which, by the way, obviously we'd love for that. We'd love for that to be Tanzu, you know, the Tanzu Kubernetes distribution, but anything will work. It's just Kubernetes after all. So let's let this run. This takes, like I said, it's doing that analysis. It's actually looking at every type on the class path and every type in your code, and it has to repeat this every single time. So it takes a long time. It kind of reminds me of the XKCD cartoon where you have the engineers on the chairs swashbuckling and goofing off, and the boss demands, "What are you doing?" and waiting for the code to compile. Okay, carry on, right? Like, this is the situation we find ourselves in this world. And so this means that the cycle and reset time, the development cycle, can be very slow. And so it's very nice that Spring makes it so that most things just work out of the box. We hope that you can take early applications, a Spring 1.0 application, update the jars to Spring Framework 6, account for whatever modules have since been deprecated in the 20-odd plus years that you wrote that code, and then just make it work. It'll just automatically work in GraalVM. Now, obviously, this is slightly contingent on how well the community embraces GraalVM as well, and we're certainly working with partners to that extent to grow that base. But right now, things are looking good. So let's go to the target directory, and we'll hit customers. And what did I do? Connection factory health indicator. Well, that's interesting. That worked. It is still early days yet, so that's okay. We can fix this by simply removing ye old actuator and resetting. Haha. See, this is why it's very important that you leave yourself a little bit of extra time. So -d, skip tests, p native, clean package, and target customers. Okay, good stuff. This will take, you know, another minute, and you can see, by the way, what it did there. It's actually running the code at compile time. This is the test, isn't it? Oh, whoops. I don't want to do the test again. Is it skip tests, p native, clean package? Okay, yeah. So why did it do that? Okay, well, whatever. What it's gonna do is it's gonna look at the code, start up the application, create a skeletal application context, and then that code, you know, that's application context components can look at and programmatically generate configuration in response to. So you can actually see that here, Spring AOT. And for example, we actually look at all the different configuration mechanisms, whether it's coming from XML or for component scanning or from Java config or functional configuration or Kotlin config. we take all those different component configuration styles. Once they get turned into bean definitions, then we can look at that bean factory full of live bean definitions, and we can write code, we generate code that reifies, that makes concrete that runtime state, so that next time you start the application in a native context, it just goes straight to having that running application. It doesn't have to bother trying to read all that configuration source and do all that reflection and all that stuff. This means that there's less need for all that reflective metadata in the final native image, first of all. And second of all, you can skip all that work in the first place because you're just going to go straight to the result of that work instead of having to redo that work. And that's what this code is here. You can see all these bean definitions that we have in our application being registered here, programmatically being registered so that the application context looks as it should in the final application. So there we are, my friends. There's our running application. It started up in 75 milliseconds, which is 75 thousandths of a second. pgrep customers, that's our PID, okay? And I want to just measure the memory, so I can say bin RSS by PID, and there's a little script, and you can see it says PS -O RSS, and then the PID. And there I'm just doing some formatting to scale it up a little bit so we can get a more readable number. But there you go. So PID, it's taking 99 megs. That application, it's Jerry, the embedded SQL 99 compliant database, and the embedded web server all takes 99 megs of RAM. You can put that in a Linux container that takes another 20, and you're off to the races. My friends, this has been fun. I hope you got something out of it. I hope you can see some of the possibilities here. Obviously, Spring Boot 3 and Spring Framework 6 are coming soon. Start.spring.io, go try it out. I have been your presenter, Josh Long. Thank you so much for having me, and I'll be happy to answer any questions if you have them.
You have a question in the chat, Josh.
What is the best image to start Kubernetes with pre-packed Azul Java? I don't know, but I'm sure that there's got to be one, right? I mean, just pick the smallest one that will work for your use cases. I'm sorry, I don't know much about the Azul inner images though. But you can actually customize the build packs so that way, when you do figure out what it is, just all of your organizational builds will have the same result, the same recipe, same quality of the image itself, and so on. Okay, well, I think that's it. I think we ran out of time, friends. Appreciate you all. Have a great day and a great weekend.